Ahoy! It's been a little bit. I'll provide a little bit of context, but if you want to jump straight into the tutorial, I will be leaving the timestamp right up here. Now, the Apple II has been a computer that, despite my age, is very nostalgic to me. When I was about 10 or 11, a friend of my dad's found one in his attic and then gave it to him, and then he gave it to me, and that's really what got me interested in programming. In fact, AppleSoft BASIC was not only one of my first programming languages, but I still have a lot of my early AppleSoft BASIC programs on a 5 1/4 inch floppy disk that I've managed to keep. And where'd you find that? Yeah, anyway, so here's the floppy disk. Now, for those of you who know anything about the infamous Steve the Woz, AppleSoft BASIC is really a excellent language for the Apple II. It doesn't seem like it would be, since it is, after all, a interpreted language, but it was definitely constructed with this particular architecture in mind, and the Apple II architecture is a little bit weird. Now, it made a lot of sense in the late 70s. There's a lot of peeking and poking of bytes in order to do things like read from the joystick or write to the PC beeper. And while it might seem not just archaic, but downright bizarre in terms of how modern computers are operated, keep in mind that most programs don't even have an operating system underneath them. Your options are use a basic interpreter or write machine language. However, there is an interesting medium point in between those two extremes that I've managed to find a lot of success in. That's right. Grab your favorite pair of striped thigh-high socks, because we are getting into C. C strikes a great middle ground between ease of use and the ability to have your code compiled so that it's not running at interpreted speeds. Now, it'll never be as fast as 6502 assembly, but I don't know about you. I'm not a huge fan of writing 6502 assembly, and I tend to avoid it whenever possible. But fortunately, due to the community of Apple II enthusiasts, we have options. So today's tutorial, I will be using a Debian Linux instance to do all of the coding and converting in, but all of this can be done in Windows, and I'll let you know what Windows analogous, what a Windows analogous workflow might look like. I would recommend, even if you're doing this on Windows, having a basic degree of terminal knowledge will go a long way, regardless of what you're doing. If you want to program just about anything, if you're interested in coding, it really is an invaluable tool to learn how to use a terminal. Even if it's just basic commands like cp, mv, ls, I will be using them in this tutorial. First thing you're going to want to do is you're going to want to acquire CC65. Now, CC65 is really easy to install on Ubuntu Linux or any other Debian-based distribution. Really, all you're going to have to do is... Okay, so sudo apt update, sudo apt install CC65. This is just going to update your repositories and install the application. It's a little bit different on Windows. If you're using Windows, you can get started just by Googling CC65 Windows download. There is information about how to build, or at least how to run the binaries for this program on the website. Now, once you've made sure that this program is in your environmental path, which if you are installing it using the command line tool, it automatically will be, you're going to get a set of binaries added to your path, more than just CC65. There is an assembler and there is a linker, and there are some shortcut binaries that combine all of the most common settings for these different applications into one easy-to-use command. Now, I've decided that I'm going to put all of the files for this particular project on my desktop, so it will be easy for you to see what I'm doing. You notice, obviously, first and foremost, I've got test.c. This is the program that I'm going to be compiling and putting onto a ProDOS disk. Let's go into Nano and take a look at what's inside. It's just, this is just a default hello world for C. Now it is, I did use the CC65 hello world program as a base because originally I thought I was going to use the whole thing, but I decided to strip out anything other than just this printf command down here because I thought it would make it a little bit easier to see all at once. Now, obviously, more complex C programs are going to have to take advantage of the idiosyncrasies of the Apple II architecture. In particular, the peek and poke commands that CC65 offers are absolutely invaluable. And I hate to say it, but you might even have to use the ASM command and enter in just a handful of machine language commands into your program to get certain things to work, like if you want to use music. But fortunately, for most examples, or if you're building something like, for example, I built a simple parser in C. I was able to run it on an Apple II with very minimal changes to get it to work. All right, so ac.jar. A program you're going to want to download after CC65 is AppleCommander. Now, obviously, there are other programs that are going to do the same thing as AppleCommander, but I have the most familiarity with this particular tool. Now, when you look up using AppleCommander with CC65, it's going to give you some information online, and unfortunately, this is not correct in the latest version of Ubuntu and the latest version of AppleCommander. So I'm going to walk you through that process a little bit later. But once you have gone to the releases page, you can download the most appropriate jar file for your particular system. Obviously, I have downloaded Linux x86-64. If you're on Windows, you'll use Win32. If you're on Mac OS X, you'll use one of these. And then once you've downloaded this .jar file, you're going to want to put it in whatever, at least for ease of use, whatever folder contains your C file, and rename it to ac.jar. You don't have to rename it to ac.jar, of course, but that will make this command line utility much easier to use. Additionally, multiple tutorials online use this particular nomenclature, so consistency is obviously going to help reduce errors in the future. Now, of course, it is a jar, which means it is a Java application. If you do not have the JRE or Java Runtime Environment in Windows, you're going to want to have to grab that from the website. On Ubuntu Linux, it's pretty straightforward. Just default JRE, and this command will acquire the latest JRE application. Lastly, you're going to notice that I have a file on my desktop named master.dsk. Now, you can pull this in from Apple Win, which is a Windows Apple II emulator, which we will be revisiting later. You can access this page from the GitHub, which is pretty easy to Google and find online. Master.dsx will be a base image with ProDOS already installed on it, which we will then be appending our compiled binary to. This makes it much easier to rapidly test our binary in the future. Now, let's get to the fun stuff. Somewhere in my history, let me get to it, then I'm going to walk you through the line. There we go. CL65 -O-T Apple II test.c. Obviously, the T flag indicates that we will be compiling for Apple II because CC65 also has targets for the Nintendo Entertainment System, the Atari Lynx, the Commodore 64, and quite a few other 8-bit 6502 based and similar architecturally based machines. Now, when we run this program, we're going to notice that it created a test binary and a test.o. I think that is an intermediate linked. I don't remember the exact word off the top of my head. I'm working off barely any sleep, but it's not important for our uses. All that's important is this binary that it has generated. Now, there are some commands online that claim to be able to allow you to use AppleCommander through the terminal, and unfortunately these are broken. So the way that I tend to use this, and it's a little bit convoluted, but I will enter in java jar ac.jar, and it will open up the AppleCommander program. I will click open, and I will click master.dsk. Now hello is just a start a disk convention that was set up by Woz himself. That's why typically you don't want to name your hello program hello.c, because it causes confusion. Now what we're going to want to do is we're going to want to click import, choose, and then our binary, which is named test. Finish. You're going to want to remember to save this. I am not wanting to save this to master.dsk because this may cause problems later on. So I will name it instead CC65.dsk. And this will create our ProDOS disk. I'll close this. Now, if you want to struggle to install Lin Apple, which is the most commonly used Apple II emulator for Linux, by all means. I did not want to do that because it is a pain in the butt. Instead, you want to use Apple Win if you value your sanity. Now, it is a Windows application. However, I do have Wine installed, and Wine seems to be working like a champ with this program. So in order to, if you want to use this on Windows, you just double-click applewin.exe and it opens right up. If you want to do this in Linux and you have Wine installed, once Wine is configured, you just go to, you just enter in wine applewin.exe, and this is our Apple II emulator. Now I'm going to open up my File Explorer real quick, and I'm going to go to my desktop, and we're going to take this cc65.dsk file and just drag it into the emulator. Now this will have loaded the disk into the drive. It started up the machine. We can see what's on the disk using the catalog command. And you will see that at block 10 and onwards, we have the test application. We could run the binary using the binary run command, brun test. And would you look at that? We have our C program working exactly as intended in the Apple II emulator. Whew, that was a bit of a mess, but it's a lot of fun once you get into a workflow and you've got some more complex programs running on the Apple II. It really is amazing, if you are used to something like AppleSoft Basic, how speedy the Apple II is in certain circumstances. Now, I won't say it's the fastest machine on the planet, and there are a lot of drawbacks to using an 8-bit machine. For example, the largest single instruction number that you can access is 255, which is absolutely nothing. But it is a lot of fun to play with this architecture and get some things off the ground. Now, if you liked this video, I promise I will be doing some more interesting videos in the future. I obviously been walking you through the process of getting a Game Boy Advance game written in 2022. There are a lot of different tutorials out there. I'm a big fan of the Butano library, and I haven't come across any tutorials that walk you through that library in particular. I also will be taking a lot of different low-end distros and installing them on my laptop, and we will be putting them to the test to see which one is the best for 32-bit machines in 2022 on a few different metrics. But regardless, I really do appreciate you guys watching this far. I'm going to go edit this video and then take a nap. So, without further ado, adieu.